I believe we're recording. I mean, I've done what I can do. All right, so let me switch cameras for my people at home so they can see the magic ensue. And let's go. So we begin our IB journey with something that should be relatively easy and old, and that is solving quadratics. And we're going to start solving quadratics using factoring and the zero product property. So when we solve by factoring, again, I'm not trying to patronize anybody, just going to go over the old basics. You need to bring everything to one side of the equation, then you can factor, and then you use the zero product property. And the zero product property basically boils down to once your stuff is factored, you just set all the parentheses equal to 0 and solve for x or y or whatever variable you're working with. That's all that means. That's what the zero product property is telling you. It says, well, if you're multiplying two things and your answer is 0, well, then clearly one or both of those things could have been 0, and that's how that works. So we're going to do these examples right quick, and I will be showing all my work because it's good note-taking. So in the first one, everything's already on one side, so we're just going to factor it. This doesn't have 3 parts, so we're not going to have to use any fancy factoring methods. This one legitimately only has a GCF, a greatest common factor. So your very first step in factoring anything should always be pulling out the GCF, and the only thing that 3x squared and 5x have in common is an x. So we get to pull an x to the front, bring it outside, and it leaves me a 3x plus 5 on the inside. Like that. So this polynomial actually has 2 factors. It has this factor, and it has this factor. And apart from the fact that I use those awful University of Miami colors, this is a really straightforward question, really easy. First thing you would do is you would set the orange part equal to 0. Well, that just means x equals 0. Yeah, anytime there's an x on the outside of parentheses, its answer is automatically 0 every single time. And now you would set the green thing equal to 0. So 3x plus 5 equals 0. And then you just solve for x. So subtract 5 and divide by 3. Really easy, really straightforward, algebra 1/2 type stuff. 2 answers. All right, cool. Oh, my handwriting is very poor, I'm aware. And it's hard to write on these things. So if ever you don't know what I wrote, don't hesitate to ask. It will not offend me in any way. Okay? All right. Part B. Well, the first step in factoring is making sure that everything's on the same side. They're not all on the same side. And I got to be real with you, I don't like when my x squared is negative. So I would prefer to bring the 5x and the 6 to the left by subtracting them both. So I would get x squared minus 5x minus 6 equals 0. And then it's just straightforward. Factoring. And I find that factoring is a tough thing for everybody. Regardless of how many years you've been in school, factoring seems to be a sticking point. So we're looking for 2 numbers that multiply to give us this negative 6 that's back here. And those 2 numbers will add to give us this negative 5. Well, 2 numbers that multiply to be negative 6 and add to be negative 5 are 1 and negative 6. So it's just going to factor to x plus 1, x minus 6 equals 0. Now, we like when things are written like this because you can legitimately see the answers without doing any work, right? You just tell me what makes the parentheses equal 0. So you can see that this one's x equals negative 1, and this one x equals positive 6. Yay! Easy math. Good review, though. Now, the next one, what's wrong with my, there it is, it's got stuck. The next one starts off the same way as part B. Not everything is on the same side. Again, I don't like when my x squareds are negative, so I'm not going to move the 6x squared. I want it to stay positive. Instead, I'm going to subtract the 11x and the 10, bring it to the other side. Now, I have to write larger than you, so I have to spill down to here. Also, this will help me stay out of everybody's way, especially yours. I'll move out of your way as often as possible. So I have 6x squared minus 11x minus 10 equals 0. And there is no greatest common factor. And this is the kind of factoring that I see a lot of our factoring skills break down. The moment there's a number for an x squared, factoring becomes less easy, less straightforward. And I don't play the guessing game. because there are three different numbers actually sets that multiply to 6. I could get 1 times 6, 2 times 3, or 3 times 2, when order matters when you're factoring. And at the end with this negative 10, it could be negative 1 times 10, 1 times negative 10, 2 times negative 5, negative 2 times 5. So there's 4 different options. So if you do the math, 3 options, 4 options, there's 12 different guess and check options for factoring. Guess and check is awful. I never guess and check. Instead, I use something called the Lizzie method. And if you don't know what the Lizzie method is, I'm about to show you. And if after I show you that's not enough, you could go to YouTube and type L-I-Z-Z-I-E, Lizzie method, and they'll show more examples of the Lizzie method happening. The Lizzie method is actually the way they teach factoring over in the UK. This is an IB class, so it's important that you see things from an international standpoint. And I love it. It's amazing. It works like this. The first thing you do is identify what A times C is. This being A, and this being C. A times C gives us negative 60. And then you figure out what B is, which you find out just by looking. B is right here. So B is negative 11. Your job is to figure out which two numbers multiply to be this negative 60, but add to be this negative 11. And hopefully you don't have to run through a whole bunch of options trying to figure out what two numbers do this. It'd be great if you got it on the very first try, so I'm just going to jump to it. The two numbers that multiply to be negative 60 but add to be negative 11 will be 4 and negative 15. Positive 4 and negative 15. And yeah, those do add to be negative 11, so we're good to go. In question B, you'll notice that I asked a similar question. I said, what two numbers multiply to negative 6 and add to negative 5? The only difference was I didn't say what multiplies to be A times C, did I? But what is A? It's 1, which means I was doing the Lizzie method. It just didn't look like it. You're about to see what the Lizzie method is, but rest assured, we were doing it. You just didn't know it because A was 1. But you'll notice that in both these sets of parentheses, they started with an X, didn't they? They both start with an X. And then the numbers that were written afterwards were the two numbers that multiplied to negative 6 and added to negative 5, weren't they? We're going to do the exact same thing down here. We're going to write our two sets of parentheses. We are going to put an X in the front of both of them. And we are going to write the two numbers that pulled this off for us. Now, those two numbers were 4 and negative 15. Positive 4 and negative 15. Positive 4, I purposely wrote it up there for a reason, negative 15. Because what makes this the Lizzie method is, right here in these factors, dividing by A. Now, you would reduce your fractions. Now, obviously, I'm not technically finished factoring. If you would like to finish factoring, what you would do at this point is take the denominators and move them to the front of the X. So this one would say 3x plus 2, and this one would say 2x minus 5. There was no guessing and checking. But you don't actually have to even go that far. The question didn't say to factor it. The question said to solve it. And in question B, once we had our two sets of parentheses that both had an X in the front, we instantly saw the answers, didn't we? It's just whatever made the parentheses equal 0. That means I see that at this step. And that's why the Lizzie method is so good. It shows you that your answers are negative 2/3 and positive 5/2. You didn't even have to finish factoring. The Lizzie method gets you to the solutions one step faster without the guessing and the checking. The hardest part about it is figuring out what the two numbers were. Good old multiplication and addition is the hardest part of factoring if you know the Lizzie method. And if you needed to see more examples of that, like I said, YouTube, L-I-Z-Z-I-E, Lizzie method for factoring. Oh, by the way, I cross my Z's. That way you never have to ask, is that a Z or a 2? I always cross my Z's. That's a handwriting thing, okay? I believe, I don't know, I haven't looked it up, but I believe the person who really, quote unquote, discovered the method, that was their name. I didn't know Luca was talking to me. I thought it was one of my jacks. Not sure which one. But yeah, I think it was named after the person that, quote unquote, discovered it. But you know what's really interesting? You know why it works? Good old transformations. You guys remember transformations from Algebra 2? He says, sadly. Real quick, because it's good review. We will be doing transformations. It's Unit 5 for us. Vertical stretch and shrink. A vertical stretch or shrink of any type of function, all it does is it multiplies the y values by some value, right? So if I say vertical stretch factor 2, you take all your y values and you multiply by 2. Guess what values it doesn't change? The x's. So what that means is he's not. It's a prank. It's somebody trying to Zoom crash us. They did it yesterday too. Anyway, so think of a parabola, because these are all parabolas, right? Parabola crosses the x-axis in two places, and both of those places have the exact same y value, 0. So if you perform a vertical stretch or shrink on a parabola, the only points that never move are the x-intercepts, the solutions. So this and this are not affected by the vertical stretch or shrink caused by that. And that is why at the end you move it to here. You're undoing the vertical stretching and shrinking, if you want to think of it that way. But vertical stretching and shrinking does not affect solutions because the y values were 0 anyway. And that's why it works. It's pretty neat. For me it is. Big old math nerd, so it's neat for me. Okay, so like I said, you need more? Go check it out. Couple things you need to remember when you're solving for x. Never, ever, ever, and this is when you're solving, divide by a variable. Never divide by a variable. Because when you divide by a variable, you have instantly eliminated one of your solutions. So never divide by a variable. See all this right here? It says 3x squared minus 6x. I divided both sides by 3x. It says my only answer is 2. However, if I had brought it to the same side and factored it, I see I have 2 answers. So that is why you never, ever, ever, when solving for a variable, divide by that variable. Okay? Don't do that. And these things I'm saying are very simple Algebra 1 or Algebra 2 kinds of things, and you'd be surprised how often they bite an IB student on the butt. Einstein couldn't do basic math. He failed basic math. You'd be surprised how often you guys are going to get caught by basic stuff. Whereas the upper level stuff you've got mastered, but the basics grab you. That's one of those basics. I can't tell you how many times I watched the juniors last year, my current seniors, divide by a variable and not get full credit for a question because they eliminated a solution. Yeah. Yes, it would always be 0. However, in certain situations, that answer was not allowed to exist anyway. So it's just better to always go with factoring. That way you can see what all the answers would have been and then decide from there which ones are allowed to exist. And that will happen in chapter, I want to say, or unit, excuse me. I want to say unit 3. You'll see things like that happen. So yes, even though technically yes, if it's a parabola or whatever, yeah, the one you eliminated was always 0, but just it's bad method. Oh, and that just led me to something. I just said that's bad method. IB doesn't care if you got the right answer. If you use a bad method, you get no credit for the question. So that's why you would never do that, because it's considered bad method. The student doesn't know basic algebra, 0 credit for the question, even though you wrote x equals 0 and x equals 2. If you divide by a variable, instantly no credit. Yes. No, those questions are stupid. Yeah, that's true. It's debatable. I was just trying to be PC as a teacher.
So if you, for example, have very, very similar equations, and once that you misread a number and you just answer a question with that misread number and got essentially the right answer with the wrong number, you would still track it.
So, Luca, right? Luca wants to know if I misread the question. I'm just for the notes. Luca wants to know if I misread a question, see a number wrong, and I do the question with the wrong number, even though my answers are ridiculously close and my method was correct, do I still get some? Would I still get credit? Hold on. Did we lose Drew? Yes, we did. Okay. Well, I just wanted to make sure that it wasn't somebody crashing with his same name. Let's see. I'm waiting for Drew to come back on. Okay, it is actually Drew. Okay, cool. We're just making sure. All right, so let me explain how that works, which we were going to go over come test time. You would lose most of the credit, but you would get some credit for using correct method. So IB will reward you for knowing how to do the question correctly, but they can't give you credit if you did the question, if you got the wrong things. You'll see. I'll show you examples of test questions and how they're graded before your first test. I promise. I will take care of you because that is the learning curve. It's how they test you and how they grade you, so it matters. Now this one over here, it says, remember, when rooting a square, when canceling a square with a square root, you have to remember that it's going to create a plus or minus situation. So what I did here is from line 1 to line 2, I decided, well, I'm going to get rid of both of those squares by square rooting both sides, right? And you go, cool, that's just going to eliminate these exponents like that. But if you forget the plus or the minus, you have lost one of your two answers. And it actually doesn't matter which side you put that plus or minus on. You could choose which side you want it on. It's unimportant. You just pick one and you do it. So what I did was I stuck it on the right side, and it actually creates two questions. It gives you a 2x minus 7 equals positive x plus 1, and it gives you a 2x minus 7 equals negative x minus 1, where I've distributed a negative sign through the sets of parentheses, and then you solve for x. And that's how you get both of them. And if you're wondering why would I have done that? I go, well, think about it. Isn't 2x minus 7 squared a parabola? And isn't x plus 1 squared another parabola? Now imagine you had two parabolas. And for ease of example, I'm going to draw one upside down. Look how many times they cross each other. Twice. Parabolas will almost always intersect each other twice. And that's why. Even if they're both pointing up or both pointing down, that will still happen, and that's what the plus or minus is doing for you. It's giving you both sides of the parabola, both the left side and the right side. That's what the plus and the minus handles for you, okay? So now you know. Tying together all those Algebra 2 concepts that might never have been tied together, but that's why. And the last example, well, this is solved by factoring lesson, but that's a fraction, right? Raise your hand if you like fractions. That's what I thought. Not a single hand went up. Nobody likes fractions. Well, I mean, I like them. But most people don't like fractions. So what I say to people is, look, if you don't like a fraction, why don't you just cancel it? Just get rid of it. We cancel all fractions the same way. Multiply by the denominator. So this one fraction is 2 over x. Its denominator is x. So the way we're going to get rid of all of our fractions is by distributing an x across everything. And if we do this correctly, there will not be a fraction anymore. It gives me a 3x squared. I'll even show the work. It gives me a 2x over x. When you multiply something to a fraction, you're multiplying it to the top. And a negative 7x. And of course, x divided by x is 1. So these two x's have canceled each other out, giving you 3x squared plus 2 equals negative 7x. And now it's one of the questions that we could have had up above. Actually, a question like question C, where we have to give everything to one side, and a does not equal 1. that's what's going on now. Let's bring the 7x over by adding it to both sides. And we get to use our Lizzie method again. Can I scroll down anymore, or am I at the bottom? I'm at the bottom, so I'm going to extend my page. You guys can write smaller than me, so you don't need to be able to extend your page. Why didn't that work? There it is. All right. The board's just lagging today. Alrighty, so Lizzie method. A times C is 3 times 2, which is 6. Our B value is 7. And it should be pretty obvious which two numbers multiply to 6 and add to 7. Oh, and by the way, we're all upper level people here. You guys are allowed to talk to me while I'm teaching. It won't, so feel free to engage. Okay. Anyway, two numbers that multiply to 6 and give you 7 are just 1 and 6. So just like what we did before, you're going to create your two sets of parentheses, and you're going to put an X in the front of both of them. Our two numbers were 1 and 6, and they were both positive. And what makes the Lizzie method is dividing by A. You do need to remember to simplify your fractions. Incorporate that stray mark right there. And now, through the zero product property, you can see your two solutions are -1/3 and -2. Ooh, that looks like an alpha. Let me fix that. Now, earlier I was talking to Kirill about you have to make sure that your answers are allowed. This is one of those times you have to make sure your answers are allowed. Because if you look at the original question, there's one number X is not allowed to be. Anybody? You can say it. 0. X is not allowed to be 0 because of this thing right here. So if for some reason I had gotten one of my solutions was X equals 0, I would have crossed it off. The word for that is extraneous solution. But that wasn't the case this time. Neither one of our answers was 0, so we are set right there. That shows you the Lizzie method a couple times and reviews for you how to solve quadratics by factoring. And I hope you all enjoyed.